wrong and what's going right in your code. So now let's break down the syntax of this. So console is our global object. That's the thing that's built into the language for us to use. Then we have a dot, and then we have a log, which is our method name. So our method is also built in. So console has multiple methods built in, but log is the one we really want to use. So you'll always type out console.log, followed by parentheses, followed by some input. The input in console log tells us what to log. We can log, you know, straight up numbers or strings directly. We can log variables. We can log variable expressions like x plus y. We can even log multiple variables separated by commas, and that will work too. It automatically puts spaces between things separated by commas. So that is how we use console.log, something called a method. And methods are a certain type of an even broader category of data type called functions. And we're going to talk a little bit more about functions as we see a couple more examples of them. So console log is a method that we will be using to debug in this class. Let's see some other cool methods built in on our math object. So math, remember, was another global object that has some other methods built into it. So math doesn't have a log. Well, actually, yes, math does have a log, but I think that has to do with exponents, not logging things out. I've never really used math log method. So if you guys want to do logarithms for some reason, you could mess around with math.log. Let's do something easier than logarithms. Let's try rounding. So if I put in 3.5 as my input into this round method, I would get 5. If I did 4.2, it would round down. So if we ever want to round something, we can use math.round. We could also use math.pow. This will do an exponent. So 4 to the power of 2, which for you guys who haven't had a math class in like 10 years, it means 4 times 4. 4 to the power of 3 would be 4 times 4 times 4, etc. And we have 4 times 4 times 4, which of course is 64. So we can take exponents using the math method. There's also a shortcut. We can also do **3. So ta-da, another way of taking a power. Let's see what else. We have something called math.seal, not like arf seal, like ceiling seal. And common mistake on the homework is to try to type out ceiling. So remember, it's seal. When we type out math.seal, that actually rounds up. Think ceiling up. So it rounds up every time, even if it's 1.000001, it still rounds up. There is a counterpart to seal, math.floor. This rounds down every single time. These things are actually more useful than you would think. So if you want to round up or down specifically, you can use floor and seal. Another math method is, and a personal favorite of mine, is math.random. No input to this one. This will create a random number between 0 and 1, always a different weird decimal number. So this is our tool for randomizing things in JavaScript. It's a built-in randomizer that gives us 0 through 1, and we can use fancy math things to create any sort of random number with this. So there you go. That is another math method. So once again, these are all things that are built into the language to make your job easier. So if you were on a data aggregation project, you could use all these things a lot to make your life easier, to not be always writing out these different strings of logic. So math functions, you're going to have a chance to practice them a bit tonight. It turns out that not only global objects have these methods. So let me show you something else. Oops. So if I wanted to store my name in memory, it turns out that different data types also have methods built in. So I could do a string method, because name is a string, on this particular string. So for example, there is one called toUpperCase. If I do name followed by toUpperCase, it will uppercase my name. As you might imagine, there is also a toLowercase. And there are a bunch of string methods. So this is another reason why we have to know what we're working with. If I created an age variable, I'm not really 98, and did age.toLowercase, we would get a error because this is not built in. It says toLowercase is not a function. If we try to run a method that doesn't exist, which means either we spelled it wrong or we just made one up, or we tried to do a string method on a number, then we would get this type error, blank is not a function. So that is another error you might keep an eye out for in the homework. So how do we know what methods go where? Once again, this is not a scenario where we should be memorizing all of them. We have documentation for that. So up here we have on MDN all of the string methods ever. Look, there are a lot. There's our two uppercase and our two lowercase that we just saw. If you want to look up string methods, you can. If you want to look up math methods, you can. If you want to look up console methods, you can. Just Google it. It's all documented, and it will tell you cool things, like, for example, the two uppercase. If I click on it, it tells me what it does. It says I cannot call this method on other variables. It shows me examples of what it looks like. Really great stuff in the documentation. So please do some Googling when you get stuck on the homework tonight. All right, so that is a little bit about string methods. And there are methods on every data type. There are a lot more methods on, for example, strings than Booleans, because Booleans aren't very exciting. Here is a Boolean one, though. Or here's one that you can do on a number. So something called toString. So if we want to turn the number 98 into the string 98, we can do age.toString, and it creates a string version of it. We could do that with a Boolean as well. So if we did true.toString, now we have the string true instead of the value true. So everything has a toString built on it. That's a really common one, but you know, there are also these really specific ones that only exist for strings or for whatever. So methods. I mentioned before that methods are something called functions, and I just want to talk a little bit more about what functions are, so you guys are prepared for that piece of the homework tonight. So think of this by itself. So let's do age.toString. So I've just done age.toString with no parentheses. This is a data type called a function. Whenever you have a method or any other function with no parentheses, it is a function. Think of it as a rule book. So this right now is the potential to create a string version of a number. We haven't actually created it, but we have the rules of how to do it. So functions are like rule books. And they're not a rule book isn't very interesting until you open the book and follow the instructions. So that in coding is called executing a function. And we do that using parentheses. So this thing without parentheses, this resolves to a function. It resolves to the rules on how to create a string. With the parentheses, now it's the actual execution. So it resolves to whatever this thing spits out, which is, of course, a string. So the resolution of a function call, and remember, a function call is just a function with parentheses, is going to be called a return value. The thing that's spit out of a function, in this case, a string version of this number, is the return value. As we saw, we also sometimes have input we put in, like, for example, math.round takes in a number. This input is called the argument. So the argument is something that we actually stick into a function. Different functions expect different numbers of arguments. Some expect none, some expect 1, some expect 3. It just depends. You can always check the documentation to see that. So a little bit of function terminology. We will be talking about functions in great length on Monday, but I wanted to introduce you to some of these ideas because it is on the homework tonight. Okay, so we have one more thing I want to explore with you guys before I set you loose, and that is this idea of control flow. So how JavaScript works is we read the first line of code, and then we read the second line of code, and we read the third line of code, and we read every single line of code until we're done. That's a basic model for understanding JavaScript or any programming language. But that's not very sophisticated. We want things that can respond to different conditions. So think about that example about incrementing someone's age. So if we have a user with an age of 98, and let's say we have a Boolean called birthday. So I'm going to call this So if it's true, then today is their birthday. If it's false, today is not their birthday. So I've just hard-coded this in a very unsophisticated way. But in a perfect world of programming, there would be a bunch of logic here that actually checked the database and compared that to the date, the current date, and saw if it was their birthday or not. But for now, we're just going to hard code this in as a Boolean for simplicity's sake. So if it is their birthday, we want to increment their age. How would we do that? Well, with an if statement. So what just happened here? I basically just said, if it is true, if this variable is equal to true, or if it is true that it is this person's birthday, then run this line of code. Otherwise, don't. So at the bottom, actually, let's practice console logging, and then we'll console log the age. So we see at the bottom here that we have, once we run all this code, they have turned 99 because today was their birthday. But we only want this line of code to run once a year. Otherwise, it would just like increment really extremely, and they would be several thousand years old before we knew it. So this if statement is something that we use when we want an optional piece of code, a piece of code that should only run sometimes. So when this is true, we run the code. When it's not true, we don't. So if this were false instead, notice that this line of code never ran. And we see that when we console log age, it's the same as it was at the start. So everything inside of these brackets, which we're going to call the if block, is optional. It's only going to run if this condition is true. So now that we have some terminology, let's break this if statement down into detail. So we start with a keyword called if. That's our way of saying we're about to start a conditional. We're about to start a piece of code that only runs sometimes. Then we write our condition. This is telling us when should the code run. Remember, it will only run when this is equal to true. So this should be a Boolean of some sort. So if birthday is true, then we run whatever is in here. So inside these two curly brackets, which is the if block, there could be 1,000 lines of code. There could be one line of code. But whatever is in there is optional. It will only run if this becomes true. Also notice that I don't need a semicolon on the end in this case because the curly brackets already kind of denote that we're ending a section. If you want to put a curly or a semicolon in, it won't break anything, but not necessary. Okay, so everything in here is just regular code, but it will only run sometimes. And notice that we also indent the code in an if block. It just makes our life easier. It's more readable. So, we could have something else in here. We could just have this console log, happy birthday, string happy birthday. All right, we'll get an error. So yes, if you want to console log something, make sure you put it in a string or you will get that type error. So notice that because this is false, the happy birthday message never ran. If we change it to true, now our happy birthday message appears. So this line 6 is only running sometimes. Okay, so let's say that we wanted an alternative. So we're like, okay, if it's their birthday, we want to say happy birthday. Otherwise, we want to do something else. We could expand our if statement to something called an if-else statement. So this is saying run the first block if this is true, and then run the second block if it's false. So we could console log not your birthday. Sucker, because we're mean. We're mean JavaScript developers. So when it's their birthday, they get a nice message, but the rest of the year, we're kind of jerks to them. So that's an else statement. So notice that the else does not have a condition. The else is responding to this condition. It's just running if it's true. It's running if it's not true. So think about this. The if statement will run sometimes. The else statement will run some other times, but they never ever could both run. Because if this condition is true, the if will always run. If it is false, the else will always run. So that is if else's for you. And as far as the syntax goes, this is a little more syntactically advanced. So I'd encourage you on the homework to Google an example of an if-else statement and just kind of copy over the syntax. You can change the condition and whatever's in the block yourself, but you'll have a hard time if you're trying to remember exactly what the syntax is for this from memory. Please Google. Google is your friend. So a couple other things about these. We could also put some sort of comparison in here, like if 3 is less than 5, which is, it is, so we get the if. Messages don't work anymore. But this can be we can plop a Boolean directly in. We can plop a variable that's equal to a Boolean in. We could do a comparison. We just need some sort of condition in here. So that is the last thing I wanted to show you guys tonight. We will explore this idea of control flow and if-else statements in great detail tomorrow, but we just wanted to introduce you to them tonight and give you a little practice on the homework tonight. Speaking of which, let me show you the homework tonight. You will be getting everything in Replit from here on out. Unless they've changed things, I believe you'll actually get access to like everything through the end of the class. You can work ahead if you want, but there's no obligation to. It might be easier if you waited for the lecture, but that's up to you. So let's look at the 2 lessons for tonight. So lesson 1 is all about reading code. So for example, we have up here these 5 variables. We want to know what data types they are. So with the first couple, it might be a little obvious, but as we go along, we're looking for what does this method resolve to? What does this comparison resolve to? What about this line of code? So ideally, you're trying to figure it out from what you know, but you could play around in Replit to try and explore. I'll talk about that in a minute. And then you just type your answers down here. Then we'll ask what these actually resolve to. So first we want to know what type they are, so something like Boolean or null. Down here we want to know what's the actual values. So what do these things resolve to? The next thing here, you'll just be reading through this little chunk of code and answering some questions. So for example, it says how many variables were declared. Let's say you think it's 8. You can just set this answer equal to 8. And you're good to go. Down here, there'll be some questions about what was logged. Once again, just set this equal to whatever you think was logged. So you'll actually be setting these variables equal to things down here. There's a little question about function calls, about arguments. Remember, arguments are the things you put in the parentheses, return values, etc. So we have a few different questions. When you are done, you can click run tests and it will give you it will say like, oh, you messed some stuff up, and you can go back through and check your work using these tests. There aren't tests for every single question, but these are helpful to know if you're on the right track. The next exercise is a little bit more actual coding. So for the first part, you actually want to go in and replace this replace me thing with, a number, a string, a Boolean, etc., etc. No need to overcomplicate this section. In this section, you replace things, do stuff with pi. I'll give you a little hint. If you type out pi, that will be short. So you could actually type out the value of pi, but you could use this nifty little variable we created for you to play with, to add 1 to pi, to subtract 1, etc., etc. So let me put that back. Down here, this one's a little tricky. You're going to be using this random number to create an if-else statement that will randomly log Marco half of the time and randomly log Polo half of the time. So once again, use this. We've given you a little syntax to get you started, but look at code examples online if you can't quite remember how to write if-else statements. And then down here, you're going to use some methods to try and create values. We have some other fun stuff, blah, da, 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 da. And there are stretch tasks, these words. These stretch tasks are not required, but are a little challenge we provide for people who maybe have a little more JavaScript experience and want to be a little more challenged. So that's a little breakdown. You can run the tests on this. I will say that I think tonight's homework is really challenging, especially for people who are brand new to programming languages. So be patient with yourself, Google things. You can always find the video for the last time this class was taught if you want a reference. And most of all, do your stand-up at the end of the homework session. My guess is you guys are gonna all have some questions on some of these things. These are designed to be challenging because we want to push you to learn. So I encourage you to attend that stand-up session at the end so you guys can talk about the places you got stuck and give insight on the things that made sense to you to other people who got stuck on them. So you'll be receiving the links to the homework soon, and then you can go ahead and edit those and play with them. The last thing I want to say is that this setup is not great for playing around with individual assignments. So for example, if you wanted to, you could copy over a piece of the homework into a brand new Replit window. And so as I kind of gave you this one already, but if you did pi plus 1 and you were curious if that worked or not, remember, you can always look up this variable. So we've assigned the variable up here, but if I'm curious what's in here, I can look it up. And ta-da, that looks like pi plus 1. Another way that you could play around with this is if you're curious about this value, directly in the homework, you could throw in console log pi plus 1. So now when I run the code, I see the console log appear down here. So there is a couple little tips of ways that you can tweak this code and not be going blindly into it. Try playing with console logs, or try opening a new REPL window so that you can take little pieces of code and play with them. So a couple things you might try on the homework tonight. So that's enough of me giving you little clues. You'll have to struggle through the rest of it yourself, but let me answer any questions you have right now before I set you loose. So I'll try and take a look at what questions are already floating out there. Oh, a question about how do we turn the homework in. There is a submit button here. So just press submit, that's all. Okay. So a question about function calls, which is unfortunately labeled a dumb question. First of all, I mean, I don't want to say there are no dumb questions because there are probably some dumb questions, but a function call question is not a dumb question. Function calls are kind of crazy things that take a while to get used to. So here is this very sophisticated question about functions. Does function call refer to when you define the function or when you actually implement the function you defined? Great question that we will be talking about in great detail next week, but I will go over it right now for you. So right now, and this is a little preview of things to come. So little hint, on Monday we will learn that we can create our own functions. Right now we're only working with functions that are built into the language, things like math.random. So we didn't have to write the logic behind this, thankfully. It exists for us. So when the JavaScript developers or ourselves write the actual functions, that's just called defining a function. When we actually refer to the variable that the function lives in, that's just looking up the function, I guess. But when we throw parentheses on the end, that is the function call. And the way I like to remember it is think of the parentheses as being a button. So the function will not run until we press the button. So you have to actually add parentheses on the end to call it. So how do you know you have a function call? Well, the easiest way is look for the parentheses. Another way is that if you run it and see that the result or the return value has popped out, you've probably successfully called the function. So great question. A question about where to find the lesson recording. They will be uploaded on YouTube after the fact. If you need an exact link, you can message someone in Slack. If you just like message me directly or put something in the main channel for this class, we'll get that to you. Unfortunately, there's a little bit of a delay where we have to actually render the video out of Zoom and then upload it. So unfortunately, you will not have access to it right away, but it will be available by tomorrow for you. Question about if we can do the homework offline. Unfortunately, no, because Replit is an online tool, so you will have to actually run it online. The only way to do it offline would be to copy it over and learn how to use the command line to run your code, and even then you wouldn't have your tests. So I would just say do the homework when you have an internet connection. All right. You will not need to uncomment anything in the homework. And in fact, if you comment things out, you will probably create problems for yourself. So in this assignment and in the assignments moving forward, leave the comments as comments unless we specifically tell you to. All right. A question about signing up for Replit. You should have already created an account and submitted that on the first night. If not, I mean, to create an account in Replit is pretty simple. You just go to repl.it and there's like a sign up button in the corner. But to get access to the homework, you have to actually be linked into us. So if you did not already create a Replit account and send that to us, I would reach out to Thomas Dillard in Slack and he can help take care of that for you. All right, I've been asked for a little hint about the if-else question. So I will give you guys a little hint because that one is tricky. So one of the homework assignments is, if I can find it, so we're saying if, I'm trying to think of a hint that won't give away too much. So we have this random number. And remember, the random number is going to be somewhere between 0 and 1. And so we have to use that random number somewhere in this condition to trigger if half the time and else the other half. So you have to figure out how to use this random variable in the condition. And then in here, you probably want to be logging Marco. So use a console log in each of these to log Marco half the time and Polo half the time. And another little hint is it does not matter which one is Marco and which one is Polo if you do it right. So that is a hint. The trickiest part is figuring out what this condition should be to make if run half the time and else run the other half. So there's a little hint for you on that one. As far as links to the homework, you will get access to that right after this lesson via your project manager. All right, I want to wrap this up so you have plenty of time for the homework. Any final questions before we go? Okay, so we're talking about, okay, sophisticated questions. So John asked about the 3 types of JavaScript, the DOM, Emacs script, and BOM, which I actually haven't worked with BOM. I'm a little embarrassed to say this, but I don't know much about that. So and this question is, will we be studying all 3? So to my knowledge, not knowing much about BOM, all these basic things that we're learning right now apply to all of them. As far as the subtle differences, for the most part, it honestly won't matter in a lot of cases, but in terms of just this intro course, there's really no need to talk about different types of JavaScript. So interesting question. That's really cool that you're looking into it enough to even be able to ask that question, but not something you need to know or worry about right now. And I apologize for not being able to give you a more detailed answer because apparently I don't even know that much about one of the types of JavaScript. I should probably go watch some YouTube videos about that so that I don't look foolish in future lectures when people ask super smart questions. All right, so I'm going to, that was kind of a sad question to end the lesson on since I wasn't able to fully answer it for you guys, but I'm going to call it because this homework is going to deserve a lot of your time and attention. So I want to make sure you have ample time for it. So good luck with that. Play around in Replit, use console logs, open another Replit window and just play with little pieces of the code. It's kind of tricky because you have to make sure you're not referring to any variables that were defined in the other one, but I think it's worth playing with. So have fun with the homework tonight. Don't sweat it, you know, like work hard, but at the same time, it's designed to be challenging. So, you know, my biggest advice on the homework for this class is don't feel stupid if you don't get it right away because like it's designed to challenge you and make you think and make you have to Google and make you have to play with it before you get it. So, okay. So that is all for tonight. Tomorrow we will be doing more JavaScript. We will do a lot more with if-elses and also start looping. So I will see you guys then, and good luck with the homework tonight. Have a great night, you guys.